Hello everyone. My name is Sanya, and today I'll talk about the OAuth 2.0. Uh, so topic for the demo is today's demo topic is OAuth 2.0. We'll discuss what it is and why it's important and how it helps applications securely access the user's data without needing the passwords. Okay. I'll also show you how it works, the real world examples of OAuth 2.0. So now let's begin the demo. First, we'll discuss why we need oath. Okay, so imagine if you have an app. Okay, imagine that you have an app and that wants to access that apps wants to access to your Google Drive to list some files. Okay, so now you don't want to share your Google password to that particular app. So here the OAuth 2.0 comes into the picture. OAuth 2.0 solves this by letting the app ask Google directly. Okay, so here when you want an app when you want your application to access the Google Drive, there you don't need to share your password. You tell your app that you directly ask to the Google. So we don't need to give the passwords to that particular app. So here we approve the request and Google gives the app token. Okay. So when the request is passed to the Google, Google provides the token to that particular app and that app uses that token to get the files without knowing your password. Okay. So this is the very simple way when you need some when one particular app needs to access your Google Drive or whichever application site and you don't want to provide the password, you don't want to share that particular password with that particular app. So using OAuth 2.0, it 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 solves this particular kind of problem. It tells that it tells the application that you yourself directly ask to the Google. Okay, the app should ask directly to the Google instead of asking us. And when the app requests to the Google, on receiving the request, the Google responds back with a token. And using that token, now that application is able to access those files of your drive. Okay, so we'll see these examples moving ahead. So now let's see the let's see what are the parts of OAuth 2.0. Okay, so the OAuth 2.0 has the source owner, right? So we are the source owner, means the user, and it has a client. Client means the app that wants to access the Google Drive, as we have taken this example. So this is the client. This is the client. And authorization server is one part which issues the token. For example, if you are asking Google for the token, so Google login server is the authorization server there. Okay. And there is a resource server as well, means the actual API, okay? Actual API, for example, the Google Drive API. Here is the resource server. These all parts work together, so your problem of sharing your password is safe. Like we don't need to share the password there, and these work together so that your password stays private. Okay, so these in this manner the OAuth 2.0 works. So like let's see how 2.0 works. Like the step by step we'll try to understand what and how it works. Okay, so when see when you want to access the when you want to when you're working on that app and that app wanted to access needs your password, but there you don't need to provide your password, so you tell app that you directly ask to the Google. So that app is now redirected you it redirects you to the login to Google, login with Google. Okay, there you approve the access. You approve access and Google, after approving, Google sends the app an authorization code. So authorization code is sent by the Google. It's sent by the Google to the particular application. Now that application exchange code for an access token. Okay. So as soon as the authorization code is received, now that app shares the access token. Apps use this token to call Google Drive. Using that token, we can call Google Drive API, and our password is safe and it never leaves Google. Okay, our password never leaves. It's very safe. So, these tokens are like both uses mainly two tokens, access token and kind another one is refresh token. These access tokens are very short-lived, so it is used to call the APIs, and the refresh tokens are the ones which are longer lived, used to get a new access token whenever it expires. Okay, so refresh tokens are nothing but whenever the token expires, it is used to get a new token, new access token as soon as the previous one is expired. Okay, so OAuth 2.0 has different grant types. OAuth, like it's suppose different grant types. One is the authorization code. Okay, it is the most secure one, but it is used by the web applications and mobile applications. The another one is the client credentials, which is machine to machine. No intervention of human or user is happening there. Okay. And third one is the resource owner password. Okay. It is the user. It is where the user gives password to the app, which is not recommended one, and fourth one is the implicit. It is for the older browser applications. Okay, so we usually use authorization code, and in our PayPal project as well, we have used authorization and client credential, these type of OAuth 2.0 grant types. So now let's see the working of this authorization and client credentials one. Okay. So now let's first begin with the client credentials one. Okay. So the client credentials grant type is used by the applications to obtain an access token outside the context of a user. Okay. As we have seen, no user, it is from machine to machine, not done by the user. Okay. So it is used to obtain an access token without the context of the user. It is used when applications itself is the resource owner and is requesting access to protected resources under its control. Okay, so the use case of this is accessing APIs from machine to machine environments. No user interaction is involved in grant type of client credentials. So here, client is the one application which is registered application with a unique ID and client secret. Okay, this client is nothing but the application which is already registered with the unique client ID and client secret. So, and the authorization server, let's say in our project, we are using the PayPal one. So the PayPal one is the authorization server. It issues the access token upon successful authentication. Okay. So how are the steps in the client credentials flow? Let's see this. First is the registration process. Here, the developer registers the application on the authorization server. Okay. After the developer registers the application, it gets a client ID and the client secret. Okay. So these two values are given after the developer registers the application. Now, what happens is now we need, as we have a client ID and client secret, now we need the access token we need. So here the what does the client does is the client sends a post request to the token endpoint. Okay, with the it sends the post request having the where it is having the client ID and client secret, whatever the client ID and client secret is given to the developer, it passes in the post request, and from there it it tells the grant type equals to client credentials, where client credentials is nothing but the client ID and the client secret. Okay, after passing this token request, it will be getting the token response. Okay, if all the credentials are valid, whatever the user has sent, those credentials are valid, then the server responds with the access token, and access token has time, in which time it will, in what time it will expire, and what is the type of the token, for example, the bearer token, or and the scope. Even it represents the scope, like it is accessible in the scope only. Okay, so here is the response given of access token response is given. Now, what does the client do? The client uses the access token in the authorization header to access the protected APIs. Okay. So now, here after getting, as the tokens are exchanged, now the user is allowed to um, it is allowed to access the protected APIs within the defined scope. Okay. So here now we can access. So main thing to note here in the client credentials one is no user login or consent is involved in this. It is only machine to machine communication. Each developer account gets a unique ID and the unique client secret. Okay, whenever the developer register, it will be getting the unique ID and the unique client ID and client secret. And after sharing this client ID and client secret, the access token is given back to the machine as a response. It defines the scope of that access token, type of that access token, and until what time it is valid. So everything is given. So this was about the client credentials. When to use this kind of client credentials as a grant type. Okay. So when you're building a server to server integrations, okay, when you need to communicate server to server, no user is involved in this process. So at that time you can use client credentials. You don't need to act on you don't need to act on behalf of a user. Okay. So in such scenarios, you can move with the client credentials as the grant. Okay. So what was the next grant type? It was the authorization, right? Authorization code. So the next one, like OAuth 2.0, here what is done is, as we already seen these steps in the client credentials. So here as well, there are similar steps, but there are certain different ways access to get the access token here. Okay. So what happens here is, first one is the registration phase. Let's say if I want to access, if I want to log into my Instagram. Okay. So as we saw, there is an app which needs your access, your Google's access. Okay. Let's say Instagram, I need to log in into Instagram. So what happens is Instagram register itself with the Google. Okay. Whenever any app is created, it registers with the Google only once. Okay. So after registering, the Google provides the client ID, which is publicly identifier for the Instagram. Okay. It provides the client ID and the client secret. Client ID is public, and the client secret is the private key, only known to the Instagram and the Google. Okay. This client ID is public and it is known to everyone. And as everyone has client ID and client secret, so client secret will be private and it will be known only to Instagram and Google. For example, when we try to log in into Instagram, we when the user clicks sign in with Google, okay, we don't need to create. If we are trying to create an Instagram, let me just open. Wait, so So let's take the example of current year. See here for the hacker rank, we are getting the option as continue with Google. Okay, we can create the new account using email ID and password. But even here we are getting these options as continue with Google and continue with Microsoft. Okay, so what happens is whenever the hacker rank register itself with Google, it registers only once, and after registering, the Google provides the client ID and the client secret. So client ID is public identifier and the client secret is a very private key and it is only known to the Instagram, sorry, it is only known to the Google and the hacker rank. Okay. So what happens is when user clicks sign in with Google here on the hacker rank, then hacker rank redirects the user to the Google's authorization server. Okay. If I try to, mine is already logged in. So if I try to click this, I'll be getting the option as login through my email ID. Okay. So when the user clicks sign in with Google, it redirects user to the Google's authorization server. Now Google shows a consent screen. Okay. So as mine is already logged in, it will ask for a consent, asking like HackerRank wants to access your profile information, and if you allow you like there are options if you allow it's on you if you need to if you are satisfied with the consent then you can allow or you can deny the access. Okay, so if user clicks on allow, then the Google generates an authorization code. Okay, so Google generates the authorization code and Google redirects the user back to the hacker rank page along with the authorization code. When we click on this, see, I have already accepted the consent here. Okay, let's see. Okay, please use a valid business email address to sign up. No. Okay, let's take any other examples of mm, login. Okay, here we can see the option as sign in with Google. It is giving the pop-up to choose an account. See, here we are getting the this pop-up of consent, okay? That Google will allow Hacker Earth to access this information. What Hacker Earth needs is your name and profile picture and your address, okay? Reviewing the hackerearth.com's privacy policy and terms of service to understand how hackerearth.com will process and protect your data. To make changes at any time, go to your Google account. Okay, so here I'm getting the pop-up that a hacker out wants to access my profile information. User can allow or deny. Okay, so we have these two options, continue and cancel. If we press on continue, what happens is Google generates an authorization code, and that authorization code is redirect Google redirects user back to the hacker or page along with the authorization code. Now what happens is hacker sends a post request to the Google's authorization server containing the authorization code, the client ID, and the client secret, which is provided by the Google on registering it, and then the redirect URL where the user should send back. Okay. So when what happens is a hacker would sends a post request to the Google's authorization server containing the authorization code. Okay, we have like if we press continue, we will be getting Google will be generating an authorization code. So after getting the authorization code, what happens is Hacker Earth sends a post request containing the authorization code which we have received now, and the client ID and the client secret which was provided during the registration time, and the redirect URI where the user should be sent back. Okay. So after sending this, Google verifies. Okay. Is the authorization code valid? Okay. Whatever authorization Google has sent, it will verify. Is it a valid authorization code? Okay. So yeah, if the authorization code is valid, one point is checked. Okay, yeah. Then the next one is, does the client ID and client secret match? Okay, as the app needs to be registered on the Google platform. Okay. So after registering, the Google itself will be giving the client ID and the client secret. So it checks, okay, does the client ID and client secret match? If yes, then yeah, the second point is also checked. Now, after getting all this thing, is the redirect URI correct? Okay, whatever URI the hacker or is sending in the post request, is it correct? So after checking all these things, if everything is valid, then Google returns an access token to the hacker. Okay. So after checking all these, the access token is given by the Google. And as Hacker Earth uses this particular access token to access the user's profile information from Google, it will access like a name and the profile picture and the email. Okay. So once I can click on continue, everything is happening behind the scene, and we will be directly we will be directly redirecting to the redirect URI where we should be sent back. Okay. It was also specified in the post request. Okay. If I try to continue here, see we will be logging here and then sign in with Google. Again, it's asking for the consent. Successfully signed in. Okay. So log in, log in with Google. What is happening? Okay, let's use this Leads for Geeks. I have already logged in. Okay, let's click on sign in, continue with Google. It is asking for the account to choose. Okay, now see, I have already logged in here. Uh, they didn't ask me for the consent because at the start only I have already I've approved the consent, and now I have logged into my profile. Okay, you can see my profile here. So yeah. So this is how the author 2.0 authorization code works. Okay, so here the client ID and client secret are issued once only when it is registered by the Google, and then authorization code is generated fresh for each login attempt. Okay, whenever you try to attempt the login. So at that time, it is freshly generated for the each login attempt, and then access token is created after exchanging the authorization code, client ID, client secret. Okay. After validating by the Google, then Google will be providing the access token, and then it allows the hacker to access the user's profile. Okay. So this was about the authorization code. Now, now we'll see where do we use auth in real life, as we have seen this. Like whenever we see Google, login with Google or login with Facebook, that's the auth 2.0. Okay, so it is also used in our project, like payment gateway. Okay, so to keep the auth secure, we need to use the HTTPs for all the requests, okay? And we need to store the tokens very securely, and we need to use proper scopes, okay? Only ask what we need, okay? Only we need to ask what you need to the application, okay, which is trying to access. So, and we need to even add the time limit where the tokens needs to be expire regularly, and then we can even refresh the token as and when needed, okay, after expiration. So the request flow in Spring Boot is like whenever the user sends the request, it goes to the Spring security. Spring sends the user to the authorization server. For example, in our example, it was Google. So here the user logs in and approves the consent. Authorization server sends token back, and then Spring uses the token to call the protected resources. So Spring Security handles most of the part automatically here. Okay. So as we have seen the example, we even see here in our project as well we are using. So let me just open and share the screen. So see here we have already coded for the access token part. Controller, SPT service engine, SPT request. Okay. See, access token contains access token type, app ID, expires in. Okay. So let me open the Postman, PayPal, create order and oath. Okay. Here we already hard coded this. Okay. If we try to click this, we will be getting the token code. Okay. So we are getting the scope where this access token is valid. Okay. And here we are getting this access token. And even it is showing the token type bearer app ID. As I told you, after registration, we will be getting the app ID and client ID and client secret. Okay, app ID expires in 32,400 millisecond. Okay, so this was all about how Auth 2.0 works. How is the mechanism? How is the flow? We have already seen, and we have seen the practical examples as well in the real world where we use login with Google or login with Facebook. Okay. So here's the end of this demo. That's